Okay, so Leetcode practice time. So in this video there are two goals. The first goal is to see how to solve this problem. So we are going to find the solution and we are going to do some coding work after that. And the second goal is to see how we should behave in a real interview. So let's get started. So in a real interview, remember the first step is always try to understand the question. If there is anything unclear, please bring up the question, and also at the same time think about the edge cases. So let's take a look at the question. It's called sliding window maximum. So you're given an array of integers nums, and there is a sliding window of size k, which is moving from the very left of the array to the very right. So you can only see the k numbers in the sliding window. So each time the sliding window moves right by one position, return the maximum sliding window. So let's see. In this example, we have sliding window size as 3, and we have the input array like this. So for the first sliding window, the maximum is 3, second one is 3 as well, third one is 5, so on and so forth, and finally we should return 3, 3, 5, 5, 6, 7. Okay, so I think overall it makes sense. Let's see some constraints. So the length of the input array is between 1 to 100k, and all the numbers is within negative 10,000 to positive 10,000, and k is between 1 to the length of the array. Okay, so I think it makes sense overall. We are not going to have empty input array, and the k is never going to be larger than the length of the array, and the k is always going to be positive integers. So I don't see any edge case at this moment. So let's see how to solve this problem. So the next step is about you discuss with the interviewer about your ideas how to solve this problem. So I think for the first part, I think the brute force solution is, as we move the sliding window, we will go through every number within the sliding window and choose the maximum within them and push into the final result. So that should work, but the runtime is going to bring the runtime is going to be O n k. N is a number n is how many numbers within the input nums array. So this is a brute force solution. So let's see how to solve it in a more efficient way. So this one we could actually use some. I think we could use some DQ. Let me explain how to use a DQ to solve this problem. So DQ is essentially you could add at the first and remove at the first, add at the end, remove at the end. So it's like you can do operations at the two ends of the queue, which is a special queue. So for the DQ, we are going to keep track of the index. So let's say for this one, let's say at the very beginning sliding window is like this. So what should we do? So first of all, we added the 0, which is the index of this number into the DQ, and then we see the 3. So when we see the 3, we see that the number is larger than 1. So within this domain, the 1 is never going to be useful because we already have the 3, which is larger than the 1. So we just keep, so in this case, we can just pop the 1, the number, the index, which is 0, from the DQ. So the principle is that when we encounter a number, if the elements within the DQ that comes at the end is smaller than the current number, then we are going to remove the elements from the end of the DQ. We keep doing this kind of operation. So the reason is, suppose we add a new number into it. So the domain for this new number is always going to cover all the previous numbers as we move the sliding window to the right. So having said that, the new solution using DQ is going to be, so first of all, we keep the index of the numbers, so which is essentially from 0 to n minus 1. And if the first element in the DQ is I minus k, which means it is out of range, then we remove it. And the third step is we will keep popping the end elements within the DQ as long as the current number is larger than that. So in this way, we are going to have a linear solution, which is a ON solution. That is because we are just going to add number or pop number from the DQ. So add once and pop once. So it's like we iterate through each number at most twice. So this brings down the runtime to be all of n. So having said that, let's start to do some coding work. So the DQ solution, we are going to do some coding work on top of it. So for code, we care about the correctness of the code, the readability of the code, and of course the speed is a factor to be considered. So let's see. We will have the integer. Let's see the max sliding max. Okay, so how to say that? Let's call it the max array. Let's call it max array. So the new int is nums.length minus k. So if it is 0, 1, 2, 3, 4, 5, 6, 7, so for 7 and the sliding window is 3, 0, 1, so there are 8 numbers. So if it is 3, then we are going to have the result size as 6. So it's actually minus k plus 1. And let's say have the rater as 0. So we are going to have I is equal to 0, I is smaller than nums.length, and the plus plus I. And before it, we are going to define the DQ using the integer. Let's say DQ is new DQ. I think it is an interface, right? DQ. I think it's an interface in my, yeah, so it is DQ. So the underlying implementation, I think it would be using linked list or array queue, whatever. Okay, so let's use the array queue though. New array queue. So we are going to, if so if the DQ is empty, dot empty. So if it is empty, then we are just going to push into it. Yeah, so if it is empty, we need to push into it. We are going to say, okay, so there are two things. One is if it is out of the range, Okay, so if it is out of the range, if it is, so there are two things. Okay. Yes. So if so we need to see if the first element is in the DQ is I minus k or not. If it's smaller than that, we need to remove it. But first of all, you need to make sure that the DQ is not empty. So if DQ dot is empty, then we have no choice but to add the index into it. So we are going to have DQ dot add a last as the I. Then we continue. Otherwise, if it is not empty, we need to make sure that the first element, if the first element is out of range, then we need to populate from it. So if dq dot peak first is smaller or equal to I minus k, then we are going to call dq dot remove first. So if it is out of the range, so if it is equal to I minus k, is it out of range? I think yes. And we are going to remove it. And the thing, and well, the DQ is, well, DQ is not empty. And the last one is smaller than the current one. And DQ dot peak last. If it is always smaller than the current stuff, smaller than let's say nums I, then what we are going to do is we are going to have dq dot remove last, and then we are going to have dq dot add last for the index, which is I. And here we need to update the max array. If I is larger or equal to k, so if it is larger or equal to k minus 1, then it's time for us to have max iter plus plus is equal to nums dq dot peak first. And finally, we will return max array. So that's pretty much about the code. Let's do some testing. So for testing, usually you go through a simple test case and explain how this piece of code is gonna work. At the same time, you will fix the logic within the code if there is any bug. So let's see, we have the array as this, and we have k as 3. So at the very beginning, we have dq as empty. So let's say this is a dq, it is empty at the very beginning. And this is a max. So when I is equal to 0, because it's empty, we are going to add 0, which is the index into it. And next time, we see the first one is not out of the range, so we are not going to remove it. We see that 3 is larger than, well, dot peak, it should be nums dot peak lost. We see that the current element, the current last element, which is smaller than 3, so we are going to pop it from it, and then finally we add the 3 index for 3, which is 1 into the DQ, and then the next, and currently I is equal to 1. So next time when I is equal to 2, we see that the DQ is not empty, and the first one is not out of the range. So we are going to, and the current lost element is larger than it, so we are going to add the 2 into the DQ. And when it is 2, we are going to have the max. We are going to add the first element in the max, which is 3 into the max array. And then the next one is minus 3. So for minus 3, it is smaller, so we are going to push I is equal to 3. We are going to put the index, which is 3, into it. And we see that the first one is not out of range, so it is still 3 for the maximum. And when I is equal to 4, we see that this is out of the range, and also the current element 5 is larger than what we have in the DQ, so we are just going to push the 4 into it, and also at the same time we are going to have the 5 added into the max array. So on and so forth, we should be able to get the final answer. So let's run this piece of code to see. Okay, so the DQ is new array Q cannot find. Let's use linked list to solve it. Yeah, so let's do a submission. Alright, so it's wrong answer. Let's see why. So input array is 1, and we have that as 1. Let's see. So if I is larger or equal to k minus 1, which is 0, then we are going to have DQ peak first. So when DQ, okay, so we just continue here. Yes, so if we continue here, then we are not going to have this max to be set. So this is essentially where the bug is. So if we remove this continue, we peak it, it should, I think it should be fine for the rest of the code. But here we add the last. So instead, I think we just need to remove those 2 lines. Yeah, so let's see. If it's not empty end, peak is this, and then we are going to remove the first. So while it is not empty, and then we add the last into it, and then yeah, okay, so let's run it again. Let's do another submission. Okay, so now we have fixed the bug and we made the code to be cleaner. So that's it for this coding question and about the solution. So if you like this video, find it a bit helpful, please help subscribe to this channel, and if you have any question, feel free to leave in the comment part. So thanks for your time watching. I'll see you next time.